Good evening all. Today we are going to discuss data structure using C++ module 2. Second part. In this part we are going to discuss stacks, the stack data types, array representations, linked representation and its applications, parenthesis matching and towers of Hanoi. Next topic is stack. A stack is a class array linear list in which insertion and removal take place at the same end. This end is called the top and the other end of the list is called the bottom. Stack follows an order, maybe in LIFO, last in first out, or philo, first in last out. A abstract data type stack. You can see it is in form of instances and operations. Already we have discussed abstract data type in module 1. Instances, we are defining linear list of the elements. One end is called the bottom and other is the top. Operations, we are having 5 functions in these operations. One is empty. As usually all the data types we are checking of abstract data type, where we are checking whether the data type is stack is empty. If it is not, return false. Otherwise, what is the size of the stack? We have to use size functions. What is return the top element of the stack? We have to use top element functions. Remove the top element from the stack. We have to use pop. From the top, if we are taking out any element, that we use function pop. If we want to push an element X in the top of the stack, we use push function. Next topic, array and linked representation. Array representation is nothing but, since stack is a linear list with the limitations that addition and deletion take place at one end, it can be derived from the class array linear list. That is nothing but representation of array as stack. Linked representation and its application. There are 2 applications of stack. In one is parenthesis matching. The string is given as bracket a plus bracket a b plus c bracket close plus d bracket close, or matching braces bracket in C++ program. What we have to do? Let the given string is given above. The algorithm to be considered like this. Get the length of the string if it scan string from left to right. Get the position in the string of the left parenthesis. Same with get the position of right parenthesis. If mismatch occurs of the pair, remove extra parenthesis. If we observe in above string, left parenthesis is on 0 and 3rd and right parenthesis on 7 and 10th. First leftmost parenthesis at position 0 should match the rightmost position of the right parenthesis 10. Similarly, left parenthesis at position 3 should match with the right parenthesis at position 7. Application of link representation, parenthesis matching. Let we are having add functions and it is being written as bracket a plus b bracket bracket and another bracket. You can see that if we analyze 5 position of left bracket and 6 position of this is left does not have any matching, hence to be removed from the string. This observation motivates us to save the position each on stack as they are encountered in a left to right scan of the given string. When right bracket is encountered, it is matched to the left bracket, if any, at the top of the stack, else it is deleted from the stack. A stack is a linear list in which insertion and removal take place and the same end. Already we have told. This end is called top and the other end of the list is called the bottom. Note, this parenthesis matching problem is the same problem bracket matching problem in C++ or message to be prompt or displayed to the user at the time of decoding C++ program. C++ program for matching the parenthesis. You can see what we have discussed above string. We are using here, we are defining parenthesis matching functions like print matching array, string and expressions. Whatever expression we have given on top, same thing. Array text integer, we are defining as integer. What is the length? Also we are defining integer expression into size. We are getting size of the string which we have defined there. It does scan expressions for between two brackets, and then we are having a for loop from I equal to 0 semicolon I less than length semicolon I incremented. There we are checking for if expression at first position equal to bracket left bracket, then we push one element, else we are checking expressions for right parenthesis and we are removing the element while using pop functions as defined below. And this is the way we are doing this function. We are writing another loop for count no match for the left parenthesis add, and we are popping the element. This function can be used for the brackets in C++ program. Second application of the link representation is wonderful application, Tower of Hanoi problem. We are given n disks and 3 towers. The disks are initially stacked on tower 1 in a decreasing order of the size from bottom to top. We are to move the disks to tower 2 one disk at a time such that no disk is ever on top of the smaller one. Let 3 towers XYZ is following example tower 1, tower 2, tower 3. In this application, we are having the code as below. White tower of Hanoi, we are defining integer n and all the 3 towers XYZ. Move the top and disk from tower X to Y and use power Z of the intermediate storage. If n is greater than 0 integer, then we are writing this code like tower of Hanoi bracket n minus 1 x comma z comma y count move top disk from tower x, and again we display to top of the tower y tower of Hanoi n minus 1 comma z comma y comma z bracket close bracket close. This is the code of this application. Thank you very much.